Most UK heat pump installers size your system based on a rough estimate of your floor area. That estimate is wrong in most cases. And when it's wrong, you end up with a system that either can't heat your home on the coldest days or one that short cycles constantly and wears out in 5 years instead of 15. The calculation that prevents both of those outcomes takes about 20 minutes. Most installers skip it entirely. This video shows you exactly what it involves and what questions to ask to confirm your installer actually did it. Heat loss calculation sounds complicated. It isn't. The core formula is this: Q equals U times A times delta T. Q is the heat loss in watts. U is the thermal conductivity of a surface, how easily heat escapes through it. A is the area of that surface in square meters. And delta T is the temperature difference between inside and outside. Let's make that concrete. Take a single exterior wall, 4 meters wide, 2.5 meters tall, so 10 square meters. It's an uninsulated brick wall, so its U value is around 1.0. Your target indoor temperature is 21 degrees. Your outdoor design temperature is -3 degrees. That's a delta T of 24. So 1.0 times 10 times 24 equals 240 watts. Just from that one wall. Now do that for every wall, every window, the roof, the floor, and add ventilation losses on top. That's your total heat loss. That's the number your heat pump needs to match. There are 6 things you need to do this calculation properly. First, surface areas. Every exterior wall separately, every window separately, the ceiling, the floor. Not just the total floor area of the house, every element that separates heated space from cold space. Get a tape measure or pull out your building plans. Second, U values. This is the thermal performance of each element. An uninsulated wall runs around 1.0 watts per square meter per Kelvin. An insulated wall drops to 0.2 to 0.3. Windows are where most people are surprised. Double glazing sits at 1.2 to 1.4, triple glazing at 0.7 to 1.0. You can find these in your energy performance certificate or estimate them based on when the house was built and what upgrades have been carried out. Third, window type and condition. It's not just the U value. Old frames that let air through around the edges perform worse than their rated U value suggests. If you can feel a draft near your windows in winter, your real losses are higher than the numbers indicate. Fourth, ventilation and infiltration, measured in air changes per hour. ACH. This is how many times per hour the entire air volume of the house is replaced with cold outside air. An old drafty house runs at 0.7 to 1.0 ACH. A reasonably tight house is 0.3 to 0.5. A modern well-sealed house is 0.1 to 0.3. If you feel drafts around doors and windows, you're at the high end. This single parameter is the most frequently overlooked in quick calculations, and it can double your total heat loss figure. Fifth, your target indoor temperature. 21 degrees for living spaces, 18 for bedrooms is standard. Every additional degree you want raises your consumption by roughly 5 to 6%. Sixth, your outdoor design temperature. This is not the average winter temperature. It's the realistic worst case for your location. Southern UK, -3 degrees. Northern UK, -6 to -8. Eastern Europe, -10 to -15. Your system needs to perform at this temperature, not at the average. You don't need to do the full calculation before your installer visit. You need a number good enough to have an informed conversation. Here's the rule. Multiply your floor area in square meters by a watts per square meter figure based on your house condition. A well-insulated modern house, 40 to 60 watts per square meter. An average house with mixed insulation, 60 to 80. A poorly insulated older house, 80 to 120 or higher. Example, a 120 square meter house with average insulation. 120 times 70 equals 8,400 watts, so roughly 8.5 kilowatts of heat loss. That's the heat pump size you need as a starting point. If your installer quotes you a 5 kilowatt unit for that house without doing any further calculation, ask them why. If they quote you a 14 kilowatt unit, ask them the same question. The numbers should be justified by actual inputs, not guesswork. The most frequent mistake I see is installers calculating heat loss based on floor area alone and ignoring three critical variables: window area, thermal bridging, and whether the house has an uninsulated basement. Windows lose heat at 2 to 5 times the rate of an insulated wall of the same area. A house with large south-facing windows or a conservatory has dramatically higher heat loss than a house of identical floor area with small windows. If your installer doesn't measure your windows separately, their calculation is wrong. Balconies and structural elements that bridge from inside to outside, called thermal bridges, create localized heat loss paths that don't show up in a basic calculation. In older construction, these can add 10 to 15% to your total figure. And an uninsulated basement or ground floor with no insulation underneath contributes significant losses through the floor, especially in older houses where the floor sits directly on earth or uninsulated concrete. A correct calculation accounts for all of these. A quick calculation done in 5 minutes on a tablet while standing in your hallway does not. Before any installer visits, do the quick calculation yourself. Measure your floor area, honestly assess your insulation level, and use the 40 to 120 watts per square meter range to get a ballpark figure. When the installer arrives, ask them, what heat loss figure are you using, and how did you calculate it? If they can answer that with specific numbers, you're in good hands. If they say something like, for a house this size, we usually put in a 10 kilowatt unit, that's not a calculation, that's a guess. In the next video, I'll show you how to read an energy performance certificate and extract the numbers you actually need for this calculation, so you can walk into that installer meeting fully prepared. In the last video, I promised to show you how a heat loss calculation works. Here's why it matters. If your installer sizes your heat pump based on square footage alone, you will end up with the wrong system, not slightly wrong, fundamentally wrong, and you won't find out until your first cold January when the system can't keep up. So let's fix that before you sign anything.